biography of Ibnu al-Haytham. Ibnu al-Haytham, or his full name, Abu Ali al-Hasan Ibnu al-Hasan Ibnu al-Haytham. Sometimes he was called as al-Basri, meaning from the city of Basra in Iraq. Ibnu al-Haytham was born in Basra in 965 during a creative era known as the Golden Age of Muslim culture. Ibnu al-Haytham died at age 74 around the year of 1014. Abu Ali al-Hasan Ibnu al-Hasan Ibnu al-Haytham, or well known as Ibnu al-Haytham or al-Hazin in Western literature. He was an Arab Islamic polymath, a physician, astronomer, mathematician, physicist, and philosopher. Is among the popular scholars of Arab Muslims. Abu Ali Hasan Ibnu al-Haytham was one of the most eminent physicists whose contributions to optics and the scientific methods are outstanding, known in the West as al-Hazin. Ibnu al-Haytham was born in 965 in Basra, and he was educated in Basra and Baghdad. Thereafter, he went to Egypt, where he was asked to find ways to controlling the flood of the Nile. Being unsuccessful in this, he feigned madness until the death of Caliph al-Hakim. He also traveled to Spain, and during this period, he had ample time for his scientific pursuits, which includes optics, mathematics, physics, medicine, and development of scientific methods, on each of which he has left several outstanding books.
Alright, to know more about Al-Hazan, let me know about the place of his birth, which is Al-Basra. Al-Basra is capital of Al-Basra Muhafaza Governorate, southeastern Iraq. It is the principal port of Iraq. Al-Basra is mean the black pebbles. It was founded during the reign of Caliph Omar in the year 638 centuries. In medieval Europe, it had the name of Balsora. It is a city on the Shatt al-Arab, 279 miles to the south end of Baghdad. Ibnu al-Haytham grew up at the time when schools and libraries flourished in the Muslim civilization. Students had access to highly knowledgeable scholars who were willing to teach a number of topics including law, medicine, mathematics, geography, history, and art. Ibn al-Haytham was trained for a civil services job and was appointed as a judge for Basra. Due to the presence of various religious movements at that time, he became disappointed with religious studies and decided to dedicate his time and effort for the study of science. He was invited by Al-Hakim to help in irrigating the flow of the Nile during the floods. When Ibn Haytham realized on his field work along the Nile that his plan to regulate the Nile's water flow by building a dam south of Aswan was impractical, he feared for his life. To avoid the potential of the deadly, he faked insanity. The education, he lived in a dorm building Kubba close to the Azhar Mosque in Cairo, teaching mathematics and physics, writing science texts, and making money by copying texts after release from house arrest. During his period confinement, he wrote his influential Kitab al-Manazir, or we call the Book of Optics. He laid out completely the new ideas about light and vision in his book, wrote around 1020 and 27. while he was in Egypt. He was a productive author. He wrote at least 96 books. Nearly half of his surviving works are on mathematics, 23 of them are on astronomy, and 14 of them are optics, with a few on other areas of science. Thank you.
Today I will present about Ibn Haytham's contribution in Islamic education and his expertise. During his life, we cannot deny that there are many contributions that he left for all mankind, especially for Islamic civilization. But today I will talk about first contribution is optics. Historic theories of vision. During Islamic Golden Age, translation of ancient writings on the science of optics offered contemporary intellectuals with very philosophical theories of vision like Galen, Ptolemy, and Aristotle. Great theories were largely spread by Islamic scholars until the first quarter of 11th century, when a new method of inquiry was introduced by Ibn Haytham himself. His design and interpretation of elegant experiments became the root source for Western understandings of optics until 17th century. The real application of the action of a lens. Late 13th century, spectacles were invented, representing the first practical use of magnification in society. He also attempted to explain binocular vision and gave a correct explanation of the apparent increase in size of the sun and the moon when near the horizon. He is known for the earliest use of the camera obscura and pinhole camera. For our knowledge, camera obscura was used as a means to study eclipse without damaging our eyes by looking at the sun directly. As a drawing aid, the camera allowed tracing the project image to produce a highly accurate representation, especially appreciated as an easy way to achieve a proper graphical perspective. A camera obscura without a lens, but with a very small hole, we call it as a pinhole camera. Ibn Haytham was the first person to firmly reject the extravision theory of vision. He believed that the objects are seen by light rays emanating from the objects, not from the eyes. He thought about this because he has their own reason. His reason is the impossibility of seeing in a dark place, inability to look at powerful light source. Third, when looking at the stars, we are able to see them light immediately. However, if light came out from the eyes, we would have to wait until it reached the stars, then return to us. Probably for the first time in history of medicine, Ibn Haytham introduced the concept of magnifying role of the convex ocular lens. Due to his many important contributions to the science of optics, he is often honored by many scholars as the father of optics. In fact, he also modified the meaning of optics. Optics is not anymore reduced to a theory of direct vision, and a geometry of the gaze with a theory of vision is associated, but also relates to the theory of light, its risks and effects as a material agent. He also sought to bring about a program of reform which led him to take up a whole range of different problems. The basic aspect of this reform was to clarify the difference between the conditions of the propagation of light and the condition of the vision of lights. Next, optics consists two parts. Firstly, a theory of vision and the associated physiology of the eye and psychology of perception. Secondly, the theory of light, which are linked geometric optics and physical optics. This is the structure of the eye by Ibn Haytham. He drew it at the book of optics. This is the example. Okay, that is my part only. Thank you.
Next, we go to the ophthalmology. Okay, Ibn al-Haytham brought about great changes in this field of science and made some discovery which made him the most prominent scientist in this field between Euclid and Kepler. He experiments in a dark room called Al-Bayt al-Muslim or dark house. The dark room was later known as an obscure camera, and none of Aristotle, Theon of Alexandria, Al-Kindi, and even Chinese philosopher could explain that was produced on screen as was from image. But Ibn al-Haytham has succeeded in explaining it in detail. After that, Ibn al-Haytham also was the first to conclude a magnifying glass. He experimented with burnt glass and from then came up a magnifying glass theory. The theory has been used in scientists in Italy and to produce the world's first magnifying glass. Besides that, Ibn al-Haytham also conducted research on light, color, and light reflection in several experiments on the measurement of angle, incidence, and refraction, as well as giving a clear first view and accurately describing various parts of eye. He also discusses many twilight and light circles around the moon and sun, as well as shadows and eclipse. He has also successfully produced light positions such as light bias and light reversal. He explained the light rays move a straight line and are distinguished by the body reflecting in the ray. Last but not least, Ibn al-Haytham is regarded as the father of modern optics for his influential book of optics and has inspired Western scientists to produce movies. And then, his theory has led to the discovery of films that were later connected and played to the audience as we can see today. So, that's all.
So, ladies and gentlemen, and now we are entering the part of other contribution of Ibn al-Haytham, which is in the field of mathematical works of Ibn al-Haytham. So, ladies and gentlemen, Ibn al-Haytham built on the mathematical works of Yusalin and Thabit ibn Qurra and went on to systemize infinitesimal calculus, conic section, number theory, and analytic geometry after linking algebra to geometry. Besides that, Ibn al-Haytham also discovered a formula for adding the first 100 natural number, and he also developed analytical geometry by establishing linkage between algebra and geometry. So, ladies and gentlemen, among the arts of Ibn al-Haytham in his mathematical works is, first of all, is Al-Hazm problem. So, what is really mean by Al-Hazm problem? So, Al-Hazm problem is actually a problem that known as Al-Hazm billiard problem, which is, it is actually a mathematical problem in geometrical optics, which is first formulated by Ptolemy in 150 AD. So, this Al-Hazm problem is actually a problem concerns about reflection of light at a spherical mirror surface. So, however, even though Ibn al-Haytham managed to actually solve this problem using the geometry method, but it will sadly still remain unsolved using the algebra method. However, in 1997, there is one mathematician named Peter M. Newman, which is from the Oxford mathematician. He managed to actually solve the Al-Hazm problem. And for the next contribution of Ibn al-Haytham in his mathematical works is in the field of geometry. So, ladies and gentlemen, Ibn al-Haytham had discovered a formula for adding the first 100 natural number, and besides that, Ibn al-Haytham also managed to solve the problem of squaring the circle using the area of lawns, but later Ibn al-Haytham still gave up on the impossible task. So, ladies and gentlemen, if you can see here, this is actually the figure of the lawns of Ibn al-Haytham, and according to Ibn al-Haytham, the two blue moons together have the same area as the green right triangle itself. So, that was actually the opinion from Ibn al-Haytham. And for the last contribution of Ibn al-Haytham in his mathematical works is in number theory. So, in his analysis and synthesis, he was among the first to realize that every perfect number is prime. However, it was said to say that Ibn al-Haytham was not able to prove this result successfully,
and this number theory was proved later in 18th century by the user. Arts of writing Ibn al-Haytham. We can say that Ibn al-Haytham is a prolific author. There is at least 200 works of Ibn al-Haytham covering a wide variety of philosophical and also scientific matters. So among the arts of writing Ibn al-Haytham are, first of all is Kitab al-Manazil. So Kitab al-Manazil is actually a most influential book that ever written in physics, and most interesting part is Ibn al-Haytham wrote this book during his period of house arrested, and this book originally written in Arabic. There is also some scholars have translated this word into Latin. So basically, Kitab al-Manazil summarized previous knowledge on vision and also on basis of al-Haytham's own experimental observation, presented new opinion and scientific information including his famous theory on vision. For the second book is Risalah fi al-Dawa or Treatise on Light. So basically, Risalah fi al-Dawa is actually a supplement from his previous kitab, which is Kitab al-Manazil. So Risalah fi al-Dawa contains further investigation on the properties of luminance and its radiant diffusion through various transparent and translucent media. And for the third book is Mizan al-Hikmah or Balance of Wisdom. So Mizan al-Hikmah discussed the density of the atmosphere and related it to altitude, and Ibn al-Haytham also studied atmospheric refraction, and he discovered that the twilight only ceases or begins when the sun is at 90 Celsius below the horizon, and attempt to measure the height of the atmosphere on that basis. And for the next book is Maqalah fi al-Qarastun, or known as Treatise on Centers of Gravity. And obviously, this book is talking about or discuss about center of gravity. And in this book also, Ibn al-Haytham had formulated the theory that the heaviness of bodies varies with their distance from the center of the earth. And for the last book is Risalah fi al-Makan, or Treatise on the Place. So Risalah fi al-Makan basically discussed the theory on the motion of a body, and he maintained that a body moves perpetually unless an external force stop it or change its direction of motion. And this was actually a precursor to the law of inertia, which later stated by the Galileo Galilei in the 16th century and now known as Newton's first law of motion.
The contribution of Ibn al-Haytham in astronomy. Astronomy is one of the oldest sciences known, study of the universe and the objects that exist naturally in space, such as moons, the sun, planets, and stars. The primary interest of Ibn al-Haytham was the explanation of phenomena by both mathematical and physical hypotheses. His interest in astronomy was motivated by the discrepancy between the Aristotelian physical and mechanistic model of the celestial spheres and the Ptolemaic mathematical model on the structure of the world, of which only the Latin translation has been published, describe the Aristotelian sublunar world of 4 elements and the Ptolemaic celestial spheres in all their complexity. His only change is to accept the theory that the solar apogee is fixed with respect to the fixed stars, as if they were material. He inserts a discussion of the perceptions of lunar and solar eclipse based on the assumption that the moon and sun are solid physical bodies. The problem Al-Hasan takes up again on the light of the moon, in which he refutes the ancient theory that the moon reflects the sunlight like a mirror. Rather, he believes that the moon is a self-illuminating body because each point on its surface broadcasts light rays in all directions, whereas each point on the surface of the mirror reflects a light ray from a single source. Here, the sun in only one direction. However, he further believed that the eye receives two primary impressions in the act of vision, light and color. Therefore, he concludes that only some physical effects of the sun's light rays on the moon renders that latter's color, and thereby its light visible. This explanation opens the possibility of reconciling Aristotle and Ptolemy for the element of which the heavenly bodies are constituted is now seen to be, though qualitatively unchangeable as Aristotle insisted, yet subject to some quantitative change which renders their light visible when they are struck by the sun's light. Next, Ibn al-Haytham, the model of the motions of each of the 7 planets, became the important book in astronomy field. And because of that, some research say that Ibn al-Haytham mastered the technique of Ptolemaic astronomy. So, this is the example of Ptolemaic system. The Ptolemaic system is the theory that the Earth is the stationary center of the universe, with the planets moving in epicelic orbits within surrounding concentric spheres.
And hi, here we go to the philosophy of Ibn Haytham. First of all, phenomenology. Ibn al-Haytham is considered a pioneer of phenomenology. He articulated a relationship between the physical and observable world and that of intuition, physiology, and mental functions. Ibn al-Haytham is said to have been a supporter of Ash'ari school of Islamic theology and opposed to teaching of Mu'tazili school. He is considered the pioneering father of modern optics. And then, theology. Ibn al-Haytham is said to have been a supporter of the Ash'ari school of Islamic theology and opposed to the views of the Mu'tazili school. So he may have been a Mu'tazili supporter himself at some point in his life. The place. The place is Risalah fil al-Makan. Ibn al-Haytham, Risalah in Place, presents a critique of concept of place topos Aristotle. The physics of Aristotle states that the place of something is two-dimensional boundary of the pregnant body which is at rest and in contact with what it in. Ibn al-Haytham disagreed and pointed out that the place al-Makan is three-dimensional emptiness imagined between the inner surface of the body. Qawl fi al-Makan. Ibn al-Haytham discourse in place. It is important treatise featuring geometric demonstration for the geometry of its place, contrary for the philosophical concept of Aristotle place, which Ibn al-Haytham rejected on mathematical ground. Medicine and physiology. Ibn al-Haytham was the first to describe the various parts of the eye and about the process of eyesight. Considered the founder of experimental psychophysics and psychology, studied by scholars for a century in his field, namely Banu Musa, Thabit ibn Qurra, and grandson of Ibrahim ibn Sinan, al-Kuhi, and Ibn Sahl.
And finally, the conclusion. From the further explanation and histories about the contribution of Ibn al-Haytham as stated earlier, we can see how the patient and determined spirit of Ibn al-Haytham towards seeking the knowledge. He was very determined and dedicated in order to find new knowledge despite he had to face several bumps in the road such as being imprisoned. Despite all of this, he does not feel despair and keeps struggle to prove about his finding in optic and other fields of knowledge. Due to his determination, as a result, many scientists keep using his writing in the field of science and others. Next, Ibn Haytham's great contribution. Ibn al-Haytham wrote extensively on physics, astronomy, and mathematics. Remains a significant figure in the history of optics, refining ideas from Greek antiquity while furthering Arab and European science. He preceded the Renaissance and Age of Enlightenment with a more correct model of vision, resolving the debate over visual extromissions versus intromissions, incorporating a clear anatomy, visual psychology, and describing many facts of visual perception. Theories and detail of his experimental work allowed it to become a manual for scientific investigation and experimentation in Europe. Ibn al-Haytham role in the development of optics, visual perception, and rational thought remains underappreciated in the optometric and ophthalmic world today. The invention of Ibn al-Haytham with the new scientific insight of Ibn al-Haytham, Muslim civilization made significant and critical contributions to the accumulation of scientific knowledge in the pre-modern age that changed the ancient world. These discoveries have shaped our homes, schools, hospitals, towns, the way we trade, travel, and our understanding of the universe. In fact, the modern world itself is in debt to Ibn al-Haytham due to his contributions to science. The end of our video. Thank you for your attention.